Okay, so here's another HL paper 1A question. We have the following situation. Two bodies collide on a horizontal frictionless surface. Body X of mass 2 kilograms moves with an initial speed of 0.8 meters per second, and then body Y is initially not moving or stationary. Okay, so and then after the collision, body X moves at an angle 90 degrees to the initial direction of motion with a speed of 0.6 meters per second. We are asked to find the magnitude of the momentum of the body Y after the collision. So you really need to understand what's happening here. So initially, I have two objects. Okay, initially, this was the setup. This was X over here, Y. Okay, and then what happened is X moved in the direction of Y. When they collided at this point, X moved upwards 90 degrees. Okay, so this is X's initial position. That's where it ended up going. And then Y, as a result of the collision, moved at an angle in this manner as shown in the diagram. Okay, so if Y was initially here at the center, it moved here. Okay, so the question is asking us, what is the magnitude of the momentum? Okay, now immediately sometimes because you're seeing a diagonal line, okay, and then you might be tempted to put in your theta there, assume angles, and separate the problem into horizontal and vertical components. Okay, although you are technically still gonna do that, okay, don't rush into the problem because the question is asking us to find the magnitude of the momentum. All right, so with that, because this is about momentum, all right, I can actually just consider the momentum of the system, all right, in the X and Y directions. All right, so recall that momentum is mass times velocity. All right, so if I'm looking at the horizontal component, okay, that would actually equal to 2 times 0.8. All right, and that will be the particular momentum in my X direction, okay, or component. Okay, so don't get confused with the M's here. This is for mass, this is for momentum. All right, and then for the momentum in the Y direction, that's going to be 2 times 0.6, okay, for the Y direction. And if you calculate that, this is going to equal 1.6, and this is equal to 1.2. All right, so I have momentum in my X component, I have momentum in my Y component. Okay, whenever the question asks us to find the magnitude, remember the technique of approaching a problem like that. This is where you use your Pythagorean theorem. You get the resultant. Okay, because remember, a diagonal line refers to that being a resultant of horizontal and vertical components. Hence, to solve this problem, I will have the resultant, or the magnitude, okay, is equal to the square root, okay, of the momentum in the X direction squared plus the momentum in the Y direction squared. Okay, and then there equals, forgot the equal sign. All right, and then this will become so mx we said is 1.6, okay, squared plus 1.2 squared. You can actually estimate here just by rounding, but the answer, okay, 1.6 times 1.6 would be 2.56, plus this is going to be 1.44. Okay, and if I add it, okay, 56 plus 44, so this is going to be the square root of 4. All right, and the square root of 4 is 2, and hence our answer is letter C. Okay, so there, this is just an example wherein you have momentum. Okay, you have collision here, objects have a certain mass, there are X and Y components, but you are asked to find the magnitude. So take note of the question. Okay, what is it asking you? Okay, so in this case, it's asking you for the magnitude, so we would just get the resultant. Please recall your Pythagorean theorem.